Imagine you have $200 billion. What do you do with it? Well, you could try to solve one of the biggest geopolitical problems on the planet. We're talking about a project so huge it's honestly hard to wrap your head around it. Building a canal to bypass the Strait of Hormuz.
So here's the deal. It all comes down to this one spot, the Strait of Hormuz. You've got 20 million barrels of oil every single day from all the major players like Saudi Arabia, the UAE, Iraq, you name it, all squeezing through this tiny 33-kilometer gap. If something happens there and it gets disrupted, bam, a fifth of the entire world's oil supply just stops cold. And trust me, that affects everything.
Which brings us to a pretty wild question, right? Instead of trying to navigate through the problem, what if you can just sail around it? Or, well, more like sail through the giant mountain range that's in the way. That's what we're going to dig into. How on earth you'd even attempt something like that?
Okay, so let's get right to it. The why. I mean, why would anyone even think about spending $200 billion to carve a path through a continent? It really boils down to just one number.
$126. That's the number. $126 a barrel. That was the peak price for oil the last time things got hairy at the Straits. And look, this isn't just about the price you pay at the pump. We're talking about the raw materials for fertilizers, plastics, medicines. I mean, literally everything our modern world is built on. So yeah, the cost of that instability, it's just massive.
You know, if you look at a map, the idea seems so simple. Just cut a straight line from the Persian Gulf to the open ocean. Easy, right? Well, not so much. Because smack in the middle of that line is the Hajar Mountain range. And this isn't just any mountain range. It's one of the most hostile, rugged places on the entire planet.
So, to really get a picture of the scale here, let's compare it to something we all know, the Panama Canal. That one is 77 kilometers long, but it was dug through mostly flat jungle. This bypass, it's actually shorter, only 32 kilometers. But, and this is a huge but, it has to go straight through vertical mountains. So even though it's shorter, the estimate is that it's about 10 times harder to build. Just think about that.
And the geology? Oh man, it's a total nightmare. This isn't some nice solid block of rock you can just blast your way through. No, the Hajar limestone is super hard, but it's also completely fractured and full of hidden caves. Plus, you're out in the middle of nowhere. I'm talking zero infrastructure. No roads, no power, not even any water. You have to build everything from scratch before you can even think about starting the canal.
And the stuff you can't see is maybe even scarier. Get this. During one of the first surveys, a drill is going down. It gets to 40 meters, and then nothing. It just drops. They'd hit a massive hidden cave system. We're talking the size of a cathedral right on the planned route. That one discovery meant the entire blast plan had to be thrown out and redesigned. So this mountain isn't just a wall, it's a hollow trap waiting to spring.
So the question is, how do you even begin to fight a mountain like that? Well, you do it with an army of engineers and a plan so complex it's almost hard to believe. Let's dive into some of the solutions.
All right, before you can move even one shovel of dirt for the canal itself, you basically have to build an entire city. Think about it. You've got to blast 180 kilometers of roads out of vertical cliffs, build a desalination plant just so everyone can have a drink of water, and then construct your own 200-megawatt power station because, hey, you're totally off the grid.
And after all that prep work, what's the reward? You get to start excavating 400 million cubic meters of rock. Let me say that again, 400 million. That is 40, that's 40 times more rock than was moved for the entire Panama Canal. The volume is just, it's staggering.
That obviously leads to the next question, what do you do with a mountain's worth of rock? Well, the answer comes with a huge environmental price tag. You just dump it all into the sea. You're literally creating new land, yeah, but you're also permanently changing the coastline, wiping out crucial marine habitats, and messing with the water quality for miles and miles.
And once this operation gets going, it is absolutely relentless. Picture this. Every 8 seconds, a blast takes out 50,000 tons of rock. It takes 90 seconds for a giant excavator to fill up a 100-ton truck. And every 30 seconds, one of those trucks is driving out of the canyon. And this isn't a 9-to-5 job. This is 24/7. The whole operation is a machine that never, ever stops.
But you know, it's not as simple as just blasting and hauling rock away. You got to remember, this mountain is broken. It's unstable. So the engineering challenge is also about taming the geology of this new canyon while you're literally carving it out of the earth.
And believe me, the mountain fights back.
As the crews dig down 120 meters, the walls of the canyon start to bleed. That's groundwater, trapped under incredible pressure, just seeping out of all those cracks in the limestone. It threatens to flood the whole site and stop everything in its tracks.
The solution they came up with is pretty brilliant, actually. They drilled a permanent dewatering network right into the canyon walls. It's basically a massive system of pumps that are always on, pulling 50,000 liters of water out of the rock every single hour. It's the only thing keeping the whole site from turning into a giant lake.
And just when you think you've seen it all, the surprises keep coming. The geologists find this huge, unstable slope. We're talking 200,000 tons of broken rock, just hanging there like a guillotine, right above where everyone is working.
But the way they responded was just insane. They evacuate 200 workers at 3 in the morning. By 8 a.m., that's only 5 hours later, the engineers have already completely redesigned that whole section. They just moved the entire route 80 meters to the south and got back to work. I mean, a problem that would shut down most projects for months, they solved it in a matter of hours.
So how do you stop the walls of this massive new canyon from just caving in? Well, you do it with 180,000 of these massive rock bolts. They're drilled deep into the canyon walls, and they're basically stitching the broken mountain back together, holding it open against its own incredible weight.
Okay, so after years of all that blasting and drilling and hauling, all that raw, violent work, it finally gives way to the last and maybe most incredible transformation, turning this giant scar on a mountain into a functioning waterway.
There's this quote from someone who was on site that just captures the sheer speed and scale of it all. He said, "I am standing inside the canal. These walls were mountains 3 days ago." Can you even imagine that? Standing on solid ground that was literally the inside of a mountain just 72 hours before. That's the reality of this thing.
Then it's time for the final touches to make this canyon an actual canal. First, you seal those fractured walls with something called shotcrete. Then you pour a concrete floor that's a whole meter thick. You install 3 colossal lock systems, and at both ends, you have to dredge 15-kilometer-long channels from the seabed. And where does all that dredged up stuff go? Yeah, it just gets dumped out in deep water, hitting the marine ecosystem yet again. Finally, to project the whole thing, you build these enormous breakwaters from 15-ton rocks.
And just to give you one last mind-blowing sense of scale, think about those locks. They have to lift supertankers over a mountain, right? Well, each lock basin is so big, you could lay the Eiffel Tower down inside it and still have room left over. These aren't just locks. They're basically concrete valleys built by people.
When you step back and look at it, this whole concept is just a stunning testament to human ingenuity, right? It shows what's possible when engineering takes on a problem that seems impossible. But it also forces us to ask a really critical question. When you factor in everything, the permanently altered coastline, the destroyed habitats, the massive carbon footprint, what is the true cost of moving a mountain?